Hi there. Okay, let's talk a couple more problems where we need to find standard deviation. And I think maybe we'll throw in one where you got to find the mean. So let's suppose that we're talking about SAT scores and you get your score report in the mail and you find out that you scored a 2000 on the SAT. They tell you that the mean score on the SAT is 1500. And they also tell you that you scored at, let's say the 80th percentile. The question then is, what's sigma? Okay, so your score was 2000. The mean score is 1500. You scored at the 80th percentile. So if you drew that picture, it would look like this. The mean at 1500, your score at 2000, and since you're the 80th percentile, this area right here is 80%. Okay? And if I write the probability statement, because that's really how you want to do this, because if you write the probability statement, it makes everything really clear exactly what you're doing. There's the probability statement. Now we'll go ahead and standardize our random variable, mu of x over sigma x less than or equal to 2000 minus mu of x over sigma of x equals 0.80. Okay, we've done the same thing arithmetically to both sides of this inequality, so algebra-wise we're still in good shape. We can do that. This term right here turns into a z random variable because we've transformed the x from a random variable that was normal with a mean of 1500 and a standard deviation of what we're trying to find out into a normal random variable whose mean is 0 and whose standard deviation is 1. And remember, that's always the case for a z random variable, or what we call a z-score. Okay? I'm going to go ahead and plug in 1500 in for mu of x, and I get 500 over mu of x. So 2000 minus 1500 is 500. That equals 0.80. On the standard normal distribution, where mean is 0, sigma is equal to 1, we need to find the z-score that will get us an 80% left tail. Okay, so we'll get our calculator out right there, and we'll go ahead and do second distribution, inverse normal, a left tail area of 80%, so 0.8, comma 0, comma 1, enter. 0.8416 is our z-score. So our z-score is 0.8416. What that tells us is if we are 0.8416 standard deviations away from the mean, we'll be at the 80th percentile in the distribution. Writing that as a probability statement, we get this. And finally, we have the magic. The z's are the same, the 80% are the same, so these two numbers have to be equal. And then we can get 0.8416 equals 500 over sigma of x, and doing some algebra, sigma of x is 500 over 0.8416, and so sigma of x is equal to 500 divided by 0.8416, 594.1065. So 594.1065. And there's another one just like the ones we were doing in class today. It's actually, I set it up as a word problem for you, so because I put it in the context of the SAT scores. Okay, let's go ahead and do a second problem, and this one we're going to tweak it just a bit. Okay, this time you get your ACT score back, and you find out, I'm going to switch to a black pen. There. You find out that your ACT score was 31, pretty good score. They tell you in your report that a 31 score puts you at the 92nd percentile, okay? And they also tell you that the standard deviation of ACTs is 3 points. Okay? What's mu? Okay, well we'll set this up the same way we set up the other one. Now, let me draw the picture here of the ACT distribution. The mean we don't know, I'll call that mu. Sigma we know is equal to 3. We know that our score of 31 puts us at the 92nd percentile. That's 0.92. So, in a probability statement, that looks like this. X is less than or equal to 31 is equal to 0.92. Let's standardize this x. X minus mu of x over sigma of x less than or equal to 31 minus mu of x over sigma of x equals 0.92. This right here turns into a z-score. Z less than 31 minus mu of x. Now we know sigma, it's equal to 3, so I'll put a 3 in there. Equals 0.92. Okay? What we need to figure out now is what z-score will get us a 92nd percentile. So there's my z distribution. What z-score will get us to a 92nd percentile? So we'll go ahead and take a look at the calculator, and we'll do inverse norm. Let me change 0.8 to 0.92, comma, 0, comma, 1. 1.4051. So that is 1.4051. What that means then is a z-score of 1.4051 standard deviations above the mean will get us a 92nd percentile. These two values here must be the same, and therefore we'll equate them. 31 minus mu of x over 3 equals 4051. So 31 minus mu is 3 times 1.4051. Okay, I'll bring the mu to this side and this term to that side. So 31 minus 3 times 1.4051 equals mu. And now we'll just go to the calculator and figure that out. 31 minus 3 times 1.4051, and we get, oops, I didn't look at it. We get 26.7847. 26.7847. Okay, so 26.7847. And there's our mean. That's how you do these problems.